Okay, this is part 2 of the projectile motion horizontal launch problem with Mrs. Elhofer. I hope you've already watched the video for part 1 because that got us to this point right here where we solved for time. Now, we figured out time in the y direction, and we chose to start with the y direction because we had the most knowns and only one unknown. Okay, now that we have time, time is actually transferable. It can be used in either direction. So now that we know what time is, it's no longer a find, it's a known. 0.35 seconds. We calculated this already, and now I know what time is, and now I can go about my business for solving for part B, which was delta x. I wanted to know how far away from the table it was going to land. So let's take a look at our given and find. We know the initial velocity is in the x direction, and it's 2.4 meters per second. We also know that objects in projectile motion do not accelerate in the x direction, so that's going to be 0. And we also know our time, 0.35 seconds. Let's take a look at our equations and see which one is going to work for us. All right, again, equation number 1 right off the bat, that's looking pretty good. I do have delta x, I do have my initial velocity, and I also have time. And my acceleration is 0, okay? My delta x is what I'm trying to find. There are no other unknowns in this equation right here. I have all these knowns over here, and delta x is my only unknown, so that one's looking pretty good. Let's just make sure though. Number 2, yep, I don't know what my final velocity is. Well, I mean, I guess my velocity is going to stay the same, so this would still be 2.4 and 2.4 and 2.4. My acceleration is 0, my time, but there's no delta x, and that's what I'm looking to solve for. So number 2 is not going to work. It doesn't even have the variable that I'm looking for. Number 3 has the variable I'm looking for. That's perfect. I need delta x. I have a, but a is 0. 2 times 0 times anything is, well, that whole part right here of this equation is going to go to 0, so that equation is not going to work for me either because I can't solve for delta x if it's being multiplied by a 0, so we're definitely going to use number 1. And again, like I mentioned, number 1 is going to be the equation we use most often. So let's copy it down here, and let's make sure we have everything in the x direction now, the horizontal direction. So I have delta x is equal to the initial velocity in the x direction times t, plus 1/2 the acceleration in the x direction times t squared. Okay, let's plug in what we know. Delta x is an unknown. I don't know what that is, so I'm going to leave it as delta x. That's what I'm trying to find. My initial velocity in the x direction was a positive 2.4 meters per second. You know what? I just don't feel like using my units in these problems because it gets a little just too cluttered. Okay, so I'm just going to put 2.4 and I'll plug my units back in later. My time is actually something that I already solved for, 0.35 seconds. And then we're going to add all of this, but well, we know that the acceleration is 0. So 1/2 times 0 times t squared, this entire chunk goes away. That's so nice because that's half of the problem right there. It makes it so much simpler. Now, all I'm going to do is take these two numbers and multiply, and that's going to give me my delta x. This is way easy. So let's take our calculator, and let's take 2.4 times 0.35, which is our time. That's going to give me 0.84. Delta x is equal to 0.84. And because it's a measurement in distance or displacement, that's going to be meters. And that's our answer. Man, this one was a lot easier than the first one. But again, we're still using the same kinematics equations. We're making sure to put everything in the correct dimension. So if you're in the x direction or the y direction, you're making sure that all those variables have x's or y's. And we're also simplifying a lot of stuff with those zeros. This is how you're going to solve pretty much every projectile motion problem. We're mostly just going to be practicing the horizontal launch problems. And now that you have this stuff written down, you'll be able to use these steps to help you solve some of the problems on your own in your packet.